Hello, in this video we will be solving system of equation using reduced row echelon form. It is the process of using reduced row echelon form. In the previous video we saw just a row echelon form, which is 1 0 0, making the first column here 1 0 0, and then you move to the next one 1 and 0, and then the third become 1, where you have the triangle in here all zeros, and the other numbers nothing, you keep them whatever constant you have. Now we're going to continue where we're going to make this row in here all zeros, this column here, the top two is zeros, and then you move to the last one zeros, and you will have two triangles looking like this. The diagonal is all ones, and the bottom and the top triangles both are zeros with some constant. And this way our answer is clear, is that z equal whatever number, y equal that number, and x equal whatever constant number in here. This method is called Gauss-Jordan elimination. And let's see this example using Gauss-Jordan elimination. So here we don't do back substitution, so right away we find the solution to the system. Okay, so the first thing where we need is to write this as a augmented matrix. So here we wrote it as an augmented matrix, and where we need here a 0, so 4 needs to be 0. So let's do that. So need 0 here. So to get a 0 at the 4, what I'm gonna do, I'm gonna multiply here by -2. So this way -2 times 2 is -4, -4 plus 4, that will give me 0. And so, and we continue for the whole row. So I have a -6, a -2, -3 is 6, plus 1 is 7, and so on. So here is the row changed. Row 3 becomes 0, 7, -7, -7. Now the next step we do is, if you remember, I have 0, I need another 0 here. Need it to be 0. Well, I'm going to use the first row, multiply by -2, and then add it to the second row. -2 r1 plus r2, add it to the second row, and that's your result is become your second row. So -2 and times 1 is -2 plus 2, and so on. So you move everything to 0, -5, 0, and 0. Now the third step here, because here I need the 1, if you remember, here I need this 1, so -5 needs to be 1. Divide everything by -1, which we have it here. And now what we need is, I see that these numbers in here, 7 minus 7 minus 7, can be reduced. So I divide the last row, or row 3, by 7, and we get 0, 1, -1, -1. Then we need a 0 at the third here, because the last triangle needs to be all zeros. So to do that, we do r2 minus r3, move to r3, we get the result here. Now once we have all these triangle zeros, I must have the diagonal equal 1. Well, that's easy. Just either you multiply by -1 or divide by -1 for row 3. And we get this answer right here. Now we go back to the top. If you remember that sequence, we need a 0 in here. And so we do r1 minus r3, move it to r1, will give us a 0 in here. And the last step is that I need this number here to be 0. Need this to be 0. So what I'm gonna do, I'm gonna say r2 minus r1, move to r1. r2 minus r1. 1 minus 1 is 0, and move to r1. And this way we get 1 0 0 1, and 0 1 0 0, and then 0 0 1 1. So this is, now I have all these zeros in here and all these zeros in here, and now it tells me that z is 1, y is 0, and then the x equal to 1, or you could start with x1, y 0, and z equal to 1, and therefore the system is 1 0 1. And this is the Gauss-Jordan elimination, or a reduced row echelon form. I hope this was helpful.